Okay, lesson 5.2 is on direct variation. I'm going to go kind of quickly through this. We discussed it in class already, but this video is for those who are still a little bit confused. You're going to need some graph paper, a pencil, and a ruler to take some notes. If you choose to, you can do your notes in a Cornell format, but for today's lesson, I allowed you to just take straight notes without setting up the Cornell notes. So here we go. Direct variation. What we wrote in class is just this. Direct variation is just a special relationship, a function that's represented with an equation y equals kx. So in your notes, all you have to do is write direct variation and write the equation y equals kx. Now y equals kx is similar to an equation that you should already be familiar with, and that's y equals mx plus b. In a direct variation equation, the k is the constant of variation, similar to m in the linear equation y equals mx plus b. The only difference is, in a y equals kx equation, there is no plus something. It's just y equals kx. The k is the constant of variation, and you can find the k at any point just by dividing y divided by x. So here are a bunch of examples to get you used to what a direct variation equation looks like. Y equals 4x. This is a direct variation equation. The constant of variation is 4. Y equals 1/3 x is also a direct variation equation. The constant of variation is just 1/3. Y minus 2x equals 0. Direct variation or not? Well, in the way it's written, it doesn't look like it, but if you add 2x to both sides, you get y equals 2x. That is a direct variation problem. 2 is the constant of variation. Here's another equation. Y minus 2 equals 3x. Now this is not a direct variation problem because it does not show up in the form y equals kx. If I add 2 to both sides, I get y equals 3x plus 2. It has this little added extra plus 2, which means that it's not a direct variation. So here's the short explanation. You will always have a direct variation if you have y equals some number times x. But if you have y equals some number times x and you add or subtract another number, it's no longer a direct variation. There's a whole lot more to direct variation, but these are just the basics that you need to have for this lesson. Now here's a summary. Whenever you have a direct variation equation, the graph will always pass through the origin. It will always pass through 0, 0. You'll never have a direct variation equation like the green lines I'm drawing. It will never look any different than what it looks like when it passes through the origin. So here are the examples. Problem 1. The question is, does this equation represent a direct variation? If so, find the constant of variation. Now, you should, by the time we're finished with this lesson, be able to just look at a problem like this and either say yes or no. But if you're still unsure, the way that you figure out whether it's a direct variation is if it fits the form y equals kx. This equation, 7y equals 2x, is close, but you have to solve for y. So you divide both sides by 7. The 7's cancel. You're left with y equals 2/7 x. And because y equals 2/7 x looks like this, this is a direct variation, And the constant of variation is just the k part, which is the 2/7. So your answer is yes it is, and k equals 2/7. In the next question, B, 3y plus 4x equals 8. It doesn't look like this direct variation equation, so you try to solve it for y. And when you solve for y, you get the y term by itself, and you do that by subtracting 4x. The 4x's cancel. You're left with 3y equals 8 minus 4x. Still looking to solve for y, so you divide both sides by 3. Y equals 8/3 minus 4/3 x. This is not a direct variation equation. It's not a direct variation equation because you have this added constant. Now you may have been able to look at the original equation and see this constant and say, not a direct variation. And in that case, you could have done none of this work and just answered it no, and that would have been okay. In the second problem, the question is, first saying, suppose that y varies directly with x. So on your paper you write y varies with x. That just says you're going to have a direct variation equation. This part will be true. Next thing you should write is that y equals 35 and x equals 5. What is the direct variation equation that relates x and y? Well, to write a direct variation equation, you have to figure out what the k is. And the k, as we wrote down earlier, is always equal to y over x. So you just take y, that's 35, and you divide it by x. That's 5. 35 divided by 5 is 7. So your constant, or your k, is equal to 7. Therefore your equation is y equals 7x. That's your direct variation equation. It's very simple, and what most people try to do is make it more complicated than it is. That's just half of the problem though. Once you figure out your direct variation equation, the second half of the problem says, what will y be when x is 9? What is y when x is equal to 9? All you do is you replace 9 in place of the letter x. 7 times 9 is 63. Y equals 63 when x is 9. Super simple. So for problem 4, there were 2 tables. You should copy the tables down. And here they are. If you need to pause the video while you copy them, go right ahead, but I'm going to continue as if you've already copied them. In this problem it says the data in the table y varies directly with x. For the data in the table, does y vary directly with x? So your job is to figure out if this table represents a direct variation. We already said the direct variation, or the k, is equal to y over x. So your job is to look at the table, figure out whether this y over this x stays constant throughout the table. Your job is to write k equals y over x would be 6 over 4. Is that the same as 12 over 8? And is that the same as 15 over 10? The question really should say, is k the same throughout the whole table? Is 6 over 4 equal to 12 over 8 equal to 15 over 10? If each of these fractions is equivalent, then your k is constant and it is a direct variation. So if you use a calculator, or if you reduce these fractions, either way, what you should find is 6 over 4 equals 1.5, and 12 over 8 equals 1.5, and 15 over 10 equals 1.5. Each of these numbers is the same, k is constant, so this is a direct variation. What's the equation? Y equals kx. K is 1.5, and that's your answer. Y equals 1.5x. In part B, you're doing the same thing. Does the k stay constant? Is y over x the same all the way throughout the table? 3.2 over negative 2, that's the first y in x. Is that equal to 2.4 over 1, and is that equal to? Now at this point, I can stop, because I'm going to recognize that 3.2 divided by a negative number will equal a negative answer, and 2.4 divided by positive 1 will equal a positive answer. Those two are not equal. This is not a direct variation. And that's it. The assignment that was given in class is lesson 5.2, number 10 through 24, even 25 through 29, and those are the proficient problems. The exemplary problems were 36 through 39. If you run into issues with this assignment, feel free to email me and ask for clarification, or come with questions in the morning during homeroom.